So we had a really good conversation this morning about least common multiples or lowest common denominators. We're going to extend that to what we do here. So today we're looking at adding or subtracting rational expressions. And the thing I want to point out from the beginning here is make sure you don't go cancel crazy with this stuff. When we're multiplying, you see something on the top, you see something on the bottom, you can cancel them. You can't do that with adding and subtracting necessarily. So as a review, we're going to simplify 5 over 8 plus 7 over 8 minus 3 over 8 and remind ourselves of the rule we have for adding and subtracting fractions. Well, we have a common denominator, so what we are allowed to do, this is basically the rule. We are adding or subtracting the numerators and writing them all over the denominator. And if I ask students why we can do that, students don't seem to know. But there's a reason. And the reason is, and you don't need to write this down, 5 over 8 is 5. It's 5/8, isn't it? 5 over 8, can I call it 5/8? Sure. And I'm going to add 7/8, and I'm going to subtract 3/8. I'm adding and subtracting the 5 and the 7 and the 3 because I'm adding similar things. It's no different than 5 puppies plus 7 puppies minus 3 puppies. You're going to end up with what I think is 9 puppies, correct? And that's the thinking here, is when you have a common denominator, then you are adding the same types of things. Another way to look at it is that, we'll get back to this in a second, I could have written this as 5/8 plus 7/8 minus 3/8. And let's face it, if I had 5x's plus 7x's minus 3x's, you'd have 9x's. So that's why we get 9/8. This is the origin of the rule. So we end up with 9 over 8. So what is the rule? Common denominator sum/difference of the numerators. And I'm not always going to be explaining it this way because, quite frankly, if it's over 8, I can say eighths, and that makes sense. If it's over x plus 1s, what am I going to say? X plus 1ths? Doesn't even really make sense. Review 2. What if I have fractions that don't have common denominators? Well, right now, and I don't think it's necessary for you to write this down, just listen to my words, we are trying to take 5/4 and add 7/8. That's very similar to taking $5 plus 7 clouds. They're different things. You can't mathematically bring them together as one item. So this is where the concept of a common denominator comes in. We want to change these. I'm going to rewrite this, and I'm going to suggest that you do the same thing, spacing things out. We need to rewrite these with a common denominator. And if you weren't here this morning, we had a really good discussion, I think. How many of you learned something from this morning? I hope. You never would have thought of doing it that way, but it works. We learned, among other things, that the lowest common denominator can also be called the least common multiple. But the lowest common denominator, and this is mainly directed at the people who weren't here this morning, but it is directed at everybody. The lowest common denominator has to have all of the factors of each old denominator. So when I look at this is 2. This is 2 times 2. 8 is 2 times 2 times 2. 3 is just 3. So we go to the first denominator, which was 4. It has a 2 and a 2. That means that our lowest common denominator needs to have a 2 and a 2. So now that 4 is inside of our common denominator. The 8 is 2 times 2 times 2, and what that means is our common denominator needs 2 times 2 times 2. But we already have 2 times 2. So all we need to do is add another 2 here. Well, multiply by another 2. And now this is represented. And if you're unsure as to what it is I'm referring to right here, this is right here, and this is right here. You don't need 5 2's, which would be the mistake of just multiplying the numbers together that we talked about this morning. It's not really a mistake, it still works, but it's going to be a fatal flaw later. And then on the other hand, we need this 3 represented. What are we going to use? Let's use blue. So we need a 3. Well, let's just put a 3 in here. So our lowest common denominator is, well, I guess we can figure out what this is. It's 24, right? And I do understand that many of you knew it was 24 before we started. But what does that mean? It means that we want to write this over 24 plus this over 24 minus this over 24. And 24 is this. This is the 24. So how do I change, looking up here, 2 times 2 to this, which is 2 times 2 times 2 times 3? I need to multiply by another 2 and a 3, right? I need to multiply this by a 2 and a 3 to get 24, which means I multiply the top by 24 as well, or by 6 as well. Not by 24. So the question is, and prior to today, you would probably just been asked by your math teacher, what do I multiply 4 by to get 24? And the answer is 6. I'm just saying we need to multiply the top and the bottom by the factors that are missing from the denominator that we're trying to get. We only had the 2 times the 2. We want the 2 times the 2 times the 2 times the 3. So when I do that on the top, I end up with 30. Just double check my arithmetic there. 5 times 2 times 3 is 30. Over here, what am I missing? Well, I've got 2 times 2 times 2. I'm missing a 3. I got to multiply the top and the bottom by 3 to get 24. And here, well, geez, all I have is a 3. I got to multiply by the 2 and the 2 and the 2. And I get it that me writing out 2 times 2 times 2 is probably more confusing than just saying I have to multiply by 8. But when we get to rational expressions, you got to write them all out separately. You need to see all of those factors. What do I get, 16? We're done. Well, we're not quite done. Now we're adding 24ths and 24ths. So we're going to have 30 24ths plus 21 24ths minus 16 24ths, 35. Okay. Is 35 over 24 simplify? Is there any factor that's a factor of 35 that's also a factor of 24? I don't think so. And as long as you didn't choose too big of a denominator, if you chose the smallest one, you would expect that it would never be cancelable, but you would be wrong. Sometimes those numerator numbers can come together in a strange way to get something which is simplifiable. I'll give you an example. Well, no, I won't. So always check to see if the final result is simplifiable, and it isn't. So now what we're going to do is just take those rules and those things that we did and start applying them to rational expressions. If I said to you we need to add these, the first thing that you always want to do when you're adding or subtracting is say, do I have a common denominator? And I do. This is really pretty easy. We can put these both together over 2y and have 8x I better not do that, and have 3x plus 5x plus 6. This is a really simple set of rational expressions to add. I can add the 3x and the 5x to get 8x. So I get 8x plus 6 over 2y. Now, and I want to try to make this as streamlined as possible. Now what we have is a single rational expression, right? And how do you simplify a single rational expression? You factor and cancel. So the fact that when you're adding or subtracting rational expressions means you put them together as a single one means that once you've done that, you've got a problem from 2 or 3 days ago that you have to simplify. So we have to factor and cancel. And there's a common factor of 2 in the numerator. There is also a factor of 2 in the denominator. I want to make sure that you appreciate something. These brackets that I'm going to put in green are not in any way necessary. I'm just trying to point out to you that they are factors which can cancel with identical factors. So the 2 over the 2 cancels, and I'm left with 4x plus 3 over y. And for everything we do today, everybody, I don't care about non-permissible values. I'm not interested. It's not the point today. Any questions with that example? All right, 3b over b minus 2 plus 2b minus 10 over b minus 2. Well, they're over b minus 2. They're both over the same denominator. And what that means is I can go ahead and rewrite it with that single denominator and have 3b plus 2b minus 2. Whoops. Minus 10. And we're going to simplify that to get 5b minus 10 over b minus 2. How many of you see that's equal to 5? Because if you don't, it's because you're not factoring it. You should factor things now. I can factor a 5 out of the numerator and have b minus 2 left over. It's over b minus 2. The b minus 2's cancel, and you're left with 5. So this whole bit of business about factoring and canceling, we're still doing that. You just have to wait till the end when you get a single rational expression. Any questions with B? All right. C, well, we're starting off slow. By the time we get to our exam, which will either be end of next week or when we get back, I haven't decided yet, things will get more complicated. But right now, these all have the same denominator. So we can put the numerators together. And this is a lesson 1 question now. In lesson 1, we learned how to simplify a rational expression. You do so by factoring and canceling. And you guys should be becoming like almost masters at factoring. Let's see, I'm looking for 2 numbers that multiply to give 12 and add to give negative 7. That's pretty easy. Negative 4 and negative 3. So p minus 4 on the top, p minus 4 on the bottom. I'm left with p minus 3. And again, everybody, I know there are non-permissible values associated with this. P is not equal to 4, but I don't care about that for the purposes of what we're doing today. It's not that important. Overall, I think that's pretty easy because the denominators were the same denominators. So now, and you'll notice beside example 1, I gave you some direction to other examples that would be similar. I'm doing the same thing here on page 334. There's similar examples to this. These do not have the same denominator. So keeping that in mind, let's rewrite this, leaving some room because we are going to have to convert these to the same denominator, which means we're going to have to be multiplying the top and the bottom of each of these expressions by certain things to find a common denominator on the bottom. And given our discussion in the seminar this morning, and given what I already told you about lowest common denominators today in class, I'd like everybody to try to find the lowest common denominator here. So don't do anything beyond that. I just want you to write lowest common denominator equals and write down what you believe it is. It's 6xy squared. And if you think that because I have more experience in math that I just look at this and know it's 6xy squared, you're wrong. I use the rule that I've taught you. I have to. I say that this denominator, and I don't know where you want to write this. I don't think you need to rewrite everything, but this is a 2 and an x and a y. This is a 3 and a y and a y. So I start with my first denominator and I say, well, if my first denominator contains a 2, an x, and a y, my common denominator better contain a 2, an x, and a y. And this one is represented in the denominator. Then I move to the 3y squared and I say, well, it's got to contain 3y squared. It's got to contain a 3 and a y and a y. I swivel my attention up to what I've written. I don't see a 3, so I need to include a 3. And now I need to have y times y. And when I look up there, I see that I've already got one factor of y. I just need another one. And when you multiply out all of these, you're going to get 2 times 3, which is 6, x times y, which is xy squared. This is right here. This is right there. They can overlap, and they probably will overlap most of the time. If they don't, then multiplying them together is the only option. Like if I had over x and over y, then it will be xy. So now we're ready to go. I'm going to get rid of this colored stuff. That was just for explanation's sake. I'm going to get rid of this. That was just for explanation's sake. You can feel free to do that kind of on the side. Now what I'm going to do is say I have to convert this to 6xy squared on the bottom, and this 6xy squared. It's just advice. You can take it or leave it. I would resist the temptation to convert these and put them together into one fraction in the same step. What do I have to do here? Well, I got to multiply by 3y on the top and the bottom. Why do I have to multiply by 3y? Because that denominator has a 2, an x, and a y already. I need another 3 and another y. Over here, I'm going to have to multiply top and bottom by 2x. So I end up with 9xy plus 2x times 5x plus 6y. And things are going to get a little bit, not complicated. Well, maybe complicated is the right word. There are some things here where it's no longer going to be just follow these steps. You have to think ahead about why we're doing what we're doing. So, with that being said, when I put these together, can somebody tell me why it's a good idea to multiply that 2x through on the top? Because there's a reason. Sometimes we will not want to. Isaac? A little louder, please. That's exactly it. We want to simplify that entire top because then maybe when we do, we can factor something out of it that happens to be a factor on the bottom. So this is going to be 10x squared plus 8. 12. 2 times 6 is 12. xy. Looking promising. I don't know if we'll be able to cancel anything, but let's find out. Well, I do, and some of you will as well. Are you okay with that step? All right. So now I have xy terms on the top. I have 9 of them and 12 of them, which is 21. And I get that. Can I factor the top? It's subtle, but I can, can't I? I can factor an x out of the top. And have 21y plus 10x over 6xy squared. And I can cancel that x on the top because it is a factor with the x on the bottom because it is a factor, and get 21y plus 10x over 6y squared. One should take a look at the original question. Is there something we could have done to give ourselves less work? Moderately less work? We could do that. I can cancel x on the top of the first rational expression with x on the bottom of the first rational expression, because x is a factor of the top and a factor of the bottom, which would have changed my common denominator to 6y squared, and we would have gotten there a little bit quicker. One of the things you want to maybe look out for, don't forget your question, I'll get to it in a second, is can you simplify something first? I'll give you a very almost childlike illustration of this, that I ask you to simplify the following. Right? I mean, you don't have a chance, do you? But what if I had, and then plus 3, and I have over 3x minus. You should know this is equal to 4. Right? Would you put these together with a common denominator and then try to simplify it? Or would you say, well, geez, that whole first expression is 1. 1 plus 3 is 4. That's an exaggerated illustration of why you would want to simplify something first. Go ahead, Ariana.
So would you not be able to get rid of the y in the second one because you're adding?
Would I not be able to get rid of... Where do we go there? There we go. Get rid of the what?
The y in the second?
No, because y is not a factor of the top. And I want to make sure everybody understands that we're just focusing right now on this, which is 5x plus 6y over 3 times y times y. The idea, since that y on the top is being multiplied by 6, but then it's being added to something else, the y on the top is not a factor. If there was also a y in here, and then we could factor that y out of the top, and there isn't one, but if we could, then we could cancel it. Answer your question? Okay. Any other questions with example 2a? Right. I did talk about this one this morning, and I'll ask the same question now that I asked this morning. How many of you see that b squared minus 9 is the lowest common denominator? And the only way you're going to see that is if you factor it first. Right? Remember, your lowest common denominator here has to contain all of the factors of each old denominator. So what have I told you have to do at every stage of this unit? Factor. If you don't factor, you can't do anything. So we'll rewrite this with everything in factored form. B squared minus 9 is b plus 3, b minus 3, minus 2b minus 10 over b plus 3. So, again, if this rule that I've told you, which works, is that your lowest common denominator has to contain all of the factors of each old denominator, then you need to look at the denominators in factored form. So the first denominator was b squared minus 9. It contains two factors of b plus 3, b minus 3. So we got it. That's in there. Our second denominator is b plus 3. So our common denominator needs b plus 3, but it's already there because it was included from the first. And I hope you see that we are going to have to multiply the top and the bottom of this the bottom denominator, the old denominator, by b minus 3, which means we multiply the numerator by b minus 3 as well. So we end up with 3b. Nope. We end up with b plus 3 times b minus 3 on the bottom. And on the top, we have 3b minus 2b minus 10 times b minus 3. And that mess on the top needs to be multiplied out and simplified, because maybe when we do multiply it out and simplify it, it factors and will allow us to cancel with a factor on the bottom. But you can't see if it factors yet unless you FOIL this out and then take it away from 3b. Any questions with that line? All right. So we're going to FOIL this out. 3b, let's see, minus, okay, here we go. 2b times b is 2b squared. 2b times negative 3, which would be my outer, would be negative 6b. Negative 10 times b is negative 10b. 3 times 10 is 30, while it's negative times negative, which is positive 30. I'll double check my FOIL. 2b squared, negative 6b, negative 10b, and 30. And this is over b plus 3, b minus 3. I've made here a mistake, which you're going to point out to me, I'm sure. And it's an intentional mistake, and it's what I call a shame. Because I have calculus students, 30-1 students and Math 31 students, who make this mistake. They're brilliant at math. They know calculus. They know trigonometry. They got all these really excellent skills. But they make this mistake, which is a grade 7 mistake. What is it? Right. I'm subtracting this whole thing. So I need to, you're thinking negative 1 times everything, but the bottom line is I have to subtract it all. I can't just go minus. If I was getting paid and I have deductions and I have $820 in tax, and I'm going to lose that. What else do I have for deductions? I also have $120 for some other thing, and I have $400 for some other thing. And I'm going to take my pay, which is maybe $3,200 and I'm going to subtract that, right? I'm going to lose all that money. How long do you think the person would be enrolled in the payroll, employed in the payroll office if they did this? Not very long would be my guess, right? They don't want to subtract 820 and then add 120 and add 400. They want to subtract that. They're subtracting all the deductions, and we have to subtract all of 2b minus 10 times b minus 3. So that set of brackets is important. A number of ways to handle it. I'm just going to clean this up first. It's 2b squared minus 16b plus 30. And there are at least 3 ways to peel off those brackets. How many of you would just say, well, I'm going to remove the brackets and switch the sign of everything in between, inside the brackets? Probably a lot of you. How many of you would take and multiply -1 by everything? A couple other people. Is there anybody that would do this? This is what I do. It's 3b minus 2b squared minus -16b minus 30. I just subtract all of them. You know, there's going to be a whole variety of different choices out there for people. You have to pick something that works for you. But you can't afford at this level to make an algebraic mistake like that. This is over b plus 3, b minus 3. I have a different question now. Earlier on, I asked, why are we multiplying out the top? To which Isaac answered, well, in case it's factorable. Why am I not multiplying out the bottom? Right. It's the same basic idea, right? We want everything in factored form in the end in case something cancels. So we're multiplying out the top to see if it factors. And if it does, we want to look at the factors of the bottom to see if something cancels. Go ahead. A little louder, please.
Earlier in the question, there was b minus 3 on the top and the bottom.
Earlier in the question, say that again?
Earlier in the question, there was the term b minus 3 on the top and the bottom.
Talking about what I have written in green?
Yeah.
Okay.
And then you put it out in red in your next step, right? So it was both on the numerator and the denominator.
Yep.
So aren't they a factor of both?
You mean right here?
One down.
B minus 3 is not a factor of the numerator right now because there's 3b minus 1 is screwing things up at the beginning. B minus 3 in this line is only a factor of the numerator if you could write it as b minus 3 in its own set of brackets times everything else being in its own set of brackets. That, me highlighting the brackets in green is really important because you will do that. You will get to this stage that you're talking about here with this arrow pointing at it, and you'll say, oh man, look at that. But that's wrong. That is as wrong as doing this. And it's probably more obvious that what I'm about to do is wrong. I can't do that, can I? The problem is you look immediately to the left of the b minus 3 and you see another set of brackets, and I think your brain screeches to a halt. Not yours, but people's brain stops and goes, oh, well, that means b minus 3 is a factor. But there's all kinds of other stuff there as well. As soon as you have this minus or plus, it separates those little factors from being a factor of the whole thing. So I want to take us back to where we were here. Okay. which is to here. Now, do you have a question? No? Okay. So, and then I removed them. Now we're going to simplify this and write everything in descending degree. There's our quadratic term. There is our linear term. And there is our constant term. It's over b plus 3, b minus 3. Yep. Oh, thank you. 19b. Now you have to factor, because we're back at the beginning now. The beginning of the unit, we had a rational expression. You said to simplify it, you factor and cancel, so we have to factor this. I hope everybody understands that the numerator of what we're looking at here is quadratic in nature, right? But I hope you also understand that factoring a quadratic that has a negative in front is a nightmare. So take that negative out. Factor the negative out so you can see what we have left, because maybe, I don't think it will, maybe what we have left is factorable and one of the factors is b plus 3 or b minus 3. Maybe it is. I don't know. I don't think it's, no. But we got to check, right? So if I take out a negative, I get positive 2b squared minus 19b plus 30 over b plus 3, b minus 3. Now, think about this. After all of this, do you agree that it would actually be pretty lucky if this was factorable? I mean, it's kind of a random event how all these numbers come together. So I wouldn't assume it's factorable. I'd do the b squared minus 4ac test. I would be willing to bet that when you calculate b squared minus 4ac, you get a negative number. But you can go ahead and check it out. Negative 19 quantity squared minus 4. I'm wrong. I don't think you get a negative. No, you won't. Minus 4 times a times c. What do you get for b squared minus 4ac? Brody? 120. It's factorable. It's a perfect square. Oh. Maybe it is, well, it is factorable. Maybe one of those factors is b plus 3, b minus 3. Okay, it's factorable. Wow. Have to be 2b and b. How can I get 19? I want 30. B minus 3. 19. They have to both be negative. I think that's right. So now, and I know what some of you will say, that we're done. Nothing cancels. What some of you would say, and I would agree with you, is since nothing canceled, is it okay to write that as the answer? Yes. But don't stop there in case something does factor and cancel. Any questions with that example? You can see how in this example, make sure, you can see how in this example, something that starts off pretty innocuous, pretty simple, gets complicated in a hurry, doesn't it? Okay. I think we have one last one to do. What's the common denominator? If there's anybody in the room that can tell me what the common denominator is right now, just by looking at it, within 5 seconds, I'll give you $100. 2, 3, 4, 5. Okay, nobody won. I know some of you were furiously trying to factor this in your head and give me an answer. I'm so glad that you didn't. We factor this. These are two basic trinomials to factor. Don't forget to leave a bit of room. Oh, I thought somebody almost had it there for a second. These are both basic trinomials to factor, two numbers that multiply to give -6 and add to give +1. That works. Two numbers that multiply to give 3 and add to give 4. That works. I would say that you should, within about 5 seconds looking at this, know that the common denominator is x plus 3, x minus 2, x plus 1. Because it has to contain, the common denominator has to contain both of these factors. So I write down x plus 3, x minus 2. It's there, right? The common denominator must also contain these two factors. And it contains already an x plus 3, so I need to include an x plus 1. Again, there's that overlap. So when I convert these, I'm going to have to multiply the top and the bottom of this by the x plus 1 to get it included in the mix. And I'm going to have to multiply the top and the bottom of this by x minus 2 to get it included in the denominator. Putting these together, you have x minus 1 times x plus 1 minus x minus 2 times x minus 2 over our common denominator, x plus 3, x minus 2, x plus 1. Oh. Can't we just do this? Am I allowed to do that? No, because I'm not canceling a factor out of the top. You can't just blindly see something somewhere and the same thing elsewhere and go, oh, well, I'm just going to get rid of it. That x plus 1 is not a factor of the top, neither is the x minus 2. In order to find out what the true factors of the top are, or what the factors of the top are, I got to multiply out all of that top, crunch it down to a single simplified expression, then factor that. So x minus 1, x plus 1 is x squared minus 1. Those are conjugates. We don't need to FOIL it. We can just go x times x minus 1 times 1. Minus, don't forget your set of brackets because you're subtracting something, x squared minus 4x plus 4. I think, boy, by now you should be fine with going from x minus 2 to x squared minus 4x plus 4. It'll be minus 2x minus 2x. This is over x plus 3, x minus 2, x plus 1. I mean, goodness sake, you don't want to multiply that stuff out. Leave it all in factored exposed form so that you can cancel it later if you have to. Remove the brackets. So I'm subtracting x squared. I'm subtracting a negative 4x, which makes it positive 4x. I'm subtracting a 4. Oh, x squared minus x squared is gone. I'm left with 4x minus 5, looks like. And given that 4x minus 5 is a binomial, and it's not factorable, I'm done. Nothing I can do with that. Every time I teach this lesson, I look at my lesson examples, and they seem kind of simple. They can get more complicated, and then I realize that they are already complicated. This is difficult stuff. This is, simplifying a rational expression is here, multiplying, dividing, adding, subtracting. It's a totally different beast. Practice problems are on page 336. You also have, of course, if you really need extra practice for this, and some might, the extra practice handouts at the end of your unit package. So get going on that. I just need to take attendance, do a couple of quick things at my computer, and then I will come around and help you out.